Or get a life, which I don't have.
You have plenty of life in you, Pauline. I've seen it.
I'm not
Wait,
dead.
never mind, I can record. Okay, so I'm gonna start now. So today we're gonna be talking about combinatorics. So combinatorics is basically just like counting. So first of all, like, what does counting really mean? So it's not just like 1, 2, 3 counting like that, but it's like first a little bit harder, like how many numbers are in the sequence 10, 11, 12, all the way to 20. Wait, I have a solution. So like, okay, so we subtract 9 from all the numbers, and we get that it's 1, 2, 3, all the way to 11. And like those correspond. So there are actually 11 here. But like, if a logical thing that you might do is 10 minus or 20 minus 10, and then you would get 10. But this actually turns out to be wrong. So like, let's generalize it. How many numbers are in A plus 1, all the way to B? You can answer in the chat. Like, yeah. So there's B minus A plus 1. And to find this, we subtract A minus 1 from every number. So the first one becomes 1, and it's just like 1, 2, 3, all the way to B minus A plus 1. So because this is just like in the form 1, 2, 3, we know that this has B minus A plus 1. So we can just apply this to do the earlier question now. So from 10 to 20, you can do 20 minus 10 plus 1, which would give 11. Okay, so now let's like add a certain number that we're adding by. So how many numbers are from 1, 6, 11, 16, all the way to 101? Wait, this might take a bit longer, so like, I don't think it's 20, but that's close. Yeah, it's 21. So yeah, you could say 20 plus equals 1, but like, that's kind of troll. Okay, so the way to do this, you notice that the pattern is that it adds it adds 5 every time. And you can just see this from doing like 6 minus 1 is 5, 11 minus 6 is 5, all the way to 101. So that's like divide by 5. That's the first thing we think of. But that gives us like a bunch of fractions. So that's annoying. And to get rid of these fractions, you can add 4 to each number. Or as what Justin said, you can subtract 1 from each number. So adding 4 gives 5, 10, 15, all the way to 105. And then now you can divide easily. So you divide by 5, and you get 1, 2, 3, all the way to 21. Okay, so how many numbers are in here? And like, think about what the pattern is first. Wait, let's rewrite it first. Yeah, Jennifer, that's right. It's always doubled. So an easier way to write this is just 5 times 2, 5 times 2 squared, all the way to 5 times 2 to the 10th. And it's easier to see how this is, how many numbers are in here now. Because let's look at only the exponents. If we look at the exponents, it goes from 0 to 11, 0 to 10, which is 11. All right. So the overall idea here, nice. Wait, let me figure out how to mute it. Okay. So the overall idea is just to do something to all the numbers to try to make it nice. Like, and nice is just in the form 1, 2, 3, ... or like something similar. So now let's do casework. Casework is like, casework is really important in like combinatorics problems and in other problems, and it's like, it's something that you'll see a lot. Even though it's kind of annoying, it's also like very useful. So the idea of casework is you take a hard counting problem and then you break it into several simpler problems that you can deal with easily. So let's look at this picture in the bottom right. How many ways are there to go from A to B? Is it 20? Yeah, it is. So the way you do this, you consider 3 cases. You consider if it goes from X, goes to X, goes to Y, or goes to Z. And also, like, you can't go backwards at all. So the first case, it passes through X. So first of all, there's 3 ways to get to X. So we have 3. And then if you want to go from X to B, there are 2 ways to go to B. So that gives 6. Also, Aiden, we actually have that problem later in this PowerPoint. So the first case, if it goes to X, then there are 6. The next case is if it goes through Y. If it goes through Y, then there's 1 way from A to Y, and then there's 4 ways from Y to B. And we can just see that from this picture. And that gives a total of 4. The third case is if it goes through Z. And here we do the same thing. It's just 2 times 5, which is 10. And to get the final answer, you just add all 3 numbers together. And this is the same answer that somebody got earlier. Okay, so casework is useful in problems that are like not combinatorics as well. So we're gonna go a little bit away from combinatorics and do like an algebra problem. So we want to find all solutions to this equation. And absolute value means the distance from 0. So like the absolute value of -5 is 5. The absolute value of like 9 is 9, and so on. So I'll let you guys think about the question for a bit. All right, so this is like a common technique with absolute value problems. We consider if this value in here is positive or negative. So the first case is if this absolute value is negative. So this occurs when 2x minus 1 is less than 0. So this means x is less than 1/2, just solving the inequality. And if that value is negative, we can write the absolute value of 2x minus 1 as negative 2x minus 1. So this is also equal to 1 minus 2x. So we let, wait, I can annotate. Okay, So now we can write this equation because we know this value is negative. And then just solving this, we get x equals -1. And it's important to check that this fits this condition. Because let's say like, what if we solve this equation and got a value like x equals 8? And that's completely possible. However, that wouldn't make this value negative, so that's not a valid solution. 5 and -1. Yes, that's right. Good job. Wait, I don't know how to go to the next slide now. Okay. The second case is if 2x minus 1 is non-negative. So this just means 2x minus 1 is not 0. And the case for this is x is greater than or equal to 1/2. And in this case, the absolute value of 2x minus 1 is simply equal to 2x minus 1. So we can write, so we can just write this equation. So now we solve this equation. This is just like a linear equation. So we solve this and we get x equals 5. Once again, we have to make sure that this satisfies this inequality, because otherwise, this will just not be a valid solution. Okay, so we combine these two, and in our two cases, the solutions are -1 and 5.
这个是那高中生，他在教 AMC 班，你想听吗？
The thing is I'm doing my chemistry.
行，那你做那
I
个。
can't be distracted together.
过来，迪伦，哥哥在上课，我给你找一个东西，过来。
Nice, that's pretty funny. I think like the majority of us can understand Chinese. All right. Oh shit, I have to get rid of this now. Here. All right, so now we're gonna do constructive counting, which is like really, it's like really useful to count other problems. All right, so here's a problem to like introduce this technique. Wait, is that how do you do that question? Asking about this question, or is it about the clear chat? All right, so let's just do this problem now. So we want to select locker. Oh, also, there was a correct answer in the chat that I saw. Okay, so you want to select locker combinations such that each one's 3 numbers. So what this means is just like you want to select 3 numbers from 1 to 50. This can be like anything. Like they can repeat as well. Yeah, there are a lot of right answers, so I'm just gonna go over this quickly. Okay. So the way you do this is, oops. Okay, so there are 50 ways to choose the first one, and then there's 50 ways to choose the second and the third. And altogether, it's just 50 times 50 times 50, which is equal to 125,000. Okay, I hope that made sense. Okay, yeah, I hope that made sense because this is the idea of like constructive counting. Basically, you want to count different things, and then you like combine them to create one, if that makes sense. Wait, did somebody actually fall for Alt F4? Don't click Alt F4. All right. Wait, yeah, okay. This answer is correct, and it can be used to solve many problems. All right, so in California, also for this question, don't compute it, or you can just use a calculator because it's annoying. So in California, a license plate is a number, 3 letters, then 3 numbers. So for example, a possibility is 5 FSL 421. So how many license plates are possible in California? I'll let you think about it for a bit. Wait, I think I'll keep chat open, but like let's try to be more productive in chat. All right, it's okay. Just like yeah, there are correct answers. Yeah, those answers in chat are correct. Okay, so the way that you would do this is using constructive counting. So basically the idea here is that like the numbers and the letters don't depend on each other. So, okay, so there are 10 choices for the first one because it's from 0 to 9. And then there's also 26 letters. So there's 26 letters for the second, the third, and the fourth. And then for the 5th to the 7th, there are 10 each. So then we just multiply these together. We get 10 times 26 times 26 times 26 times 10 times 10 times 10. And then we get this value. So we can see that if you search up California's population, it's about 40 million. So this means we currently have enough, but it's possible we might have to change soon. Okay, so the next one, let me clear these. All right, so this is a problem that was posted in the chat earlier. So you want to do how many rectangles are in this 5 by 5 grid. This is not very easy. It requires like a trick that's not like not that easy to think of unless you see it. I mean, like, yeah, that's the answer, but yeah. I'll let you think about like how you would do this for a bit. Oh wait, really? Not many people take ALPS counting though. Like I never took it, I think. Wait, algebra 1? Like at school? I don't know. Okay. So we have this 5 by 5 grid right here. And you want to select like rectangles. And just a few notes that were in here. A possibility is like the entire thing. That's good enough. And that's like a rectangle as well. And so are squares as shown here. All right. So let's think about like this question in a different way. So let's select 2 columns and 2 rows. And this creates a rectangle. And also we can think about how every rectangle is defined by 2 columns and 2 rows. So this is easier to count, as we'll see later. Because the other way to do this is like casework based off of every possible size, which is very difficult. Or it's not difficult, it's just annoying. Yeah, it's tedious. So, oh wait, I made an error in this. It's okay. This red arrow should be pointing here. Okay, so now what we want to do is we want to choose 2 rows, because after we choose 2 rows, it's like symmetrical for the columns, and that's so we can just square the value. So the way to choose 2 squares, there are 6 for the first choice. There are 6 rows. So the first one has 6 choices, and the second one has 5 choices. So yeah, I'm explaining how to choose that now. Okay, so, and the second one has 5 choices. So this means there's 6 times 5 ways to choose the rows. However, there's a little problem with this. Let's say you choose this row first, and then you choose this row. Notice that this is equivalent to choosing this row, and then this row. So we're counting each one twice. And to get rid of this, we divide by 2. So there's 15 ways to choose the rows. And this idea of like overcounting and then dividing is like permutations and combinations. This is a combination. And people will often write this as 6 choose 2. And we're probably going to learn more about this later. I don't know if it's going to be today. Wait, it's probably going to be today. But if not, it's going to be next week. Okay, so now by symmetry, there are 15 ways to choose the columns. So this is now constructive counting. So there's 15 ways to choose the rows, and there's 15 ways to choose the columns. So you want to choose rows and columns. So the way you do this is you multiply them together, and it's just 15 times 15 is 225. Okay, so now we're going to do complementary counting. Okay, so the problem is you choose 2 integers from 1 to 10. How many possibilities are there such that you roll? Oh wait, you don't roll. Okay, that you choose at least 1 6. Yeah, Aiden, that's correct. That's the main idea in this problem. So what's the probability that you don't choose any 6s? Wait, notice that this is 1 to 10. This is not rolling. Choose. Oh, also you choose them with replacement. So like, you can choose the same number twice. Yeah, that's 19, I think. Wait, is it 19? No, it's 19. Okay, yeah, you can casework this. And the way you would do this, or like casework is possible. The way you would do this is like 6, then something, and then 6 something, and then 6, and then you subtract the possibility of 6, 6. And this would be 10 plus 10 minus 1. But this is annoying. So we're not going to do casework. Yeah, some people are saying subtract 81 from 100. Okay, so what's the probability that, or how many possibilities are there such that there's no 6s? Well, so each one has 9 choices. And this gives a total of 9 times, wait, what? Wait, I'm bad. 1 sec. I made another typo. This is 9 times 9 equals 81. Because the first one, it can be from 1, 2, 3, 4, 5, 7, 8, 9, basically anything but 6. So both of them have 9 choices. So it's 9 times 9 that do not work. And then the total is 100. These are both just complementary counting. All right, so you have 100 total, and you have 81 that don't work. So this means that there are 19 that do work. And that's the answer. Wait, yeah, Jennifer, this is the first time using the slideshow. And also, this is kind of the end, but whatever. Okay, so that means there are 19 that do work. So now what we're gonna do is we're gonna go through an AMC 8 and just solve problems. Because why not? Can you see my screen? Someone choose a number from 1 through 10. Wait, Aiden, there's a lot of other stuff that we haven't covered. Like permutations and combinations. And then maybe we'll go through stars and bars. No, don't clear chat. Maybe we'll go through stars and bars next week. And Charlie's gonna teach that. All right, what problem do you want to start on? Okay. Do you want to start from 25? Stars and bars. Basically stars and bars, the idea is, let's consider the equation like a plus b plus 1, a plus b plus c equals 1. Wait, I can count. Or no, I can do this. Okay, so stars and bars, the idea is like, let's have the equation this. No, let's have that. Then, a, b, c, positive integers. And we want to count how many possibilities there are for a, b, c. So we're gonna go through this more, but this is stars and bars, and it just counts how many possibilities there are. Somebody requested 2020 AMC 8 number. Oops. Wait, somebody requested 2020 AMC 8 number 25. I actually haven't done this wrong. I haven't taken the AMC 8. 1 sec. Can you see my screen, by the way? Oh, wait. Okay. This problem is like, it might be a bit too difficult. Yeah, this problem is stars and bars. We're gonna teach this next week. So maybe we'll do this as a problem next week. Okay, so let's just go back to this AMC8. Wait, where is it? Okay, 2012. What problem do you want to start on? '23. Wait, how about I'll go backwards? I'll start with number 25. I think this is doable. Why do you have a haiku? Because I was doing English homework. All right, so we have a square with area 4 inscribed in a square with area 5. Okay, so let's say, so we're given the area of this big square is 5, and the area of this small square is 2. And notice that the side length of, so we know that a plus b is the side length of the big square. And then that means a plus b squared is equal to 5. So this is the first step in the problem. And then we notice that due to symmetry, this length is equal to b, this is equal to a, b, and like so on throughout. So let's consider one of these, right? Okay, let's consider one of these triangles. Oh wait, just kidding, I'm bad. This is like why, this is how you can tell it's a live solve, because I messed up and this is wrong. All right, so one of the red triangles, yeah, it's 1/2. The area is equal to AB over 2. And the way we know this is just base times height. Nice annotations. Okay, so the difference between big and small triangle is equal to red triangle times 4. Because there are essentially 4 of these right triangles, or 4 of these red triangles that separate the big squared from the small square. Okay, so the next step is, you know that the difference between the two triangles is 5 minus 4 equals 1. Yeah, Jennifer is right. The area of red triangle, we'll denote that to be area, is equal to 1/4. So we have AB over 2 equals 1/4, and AB equals 1/2. So the answer, as always, is C. Wait, how do you take? Oh yeah, I took AP Chinese, but College Board is bad and the exam did not load. All right, so that's it for. Okay, yeah, that's it for problem 25. I think we'll do an easier question. I don't want to do hard questions. Okay, I'm gonna RNG this. Or we're gonna do 17. All right, so we want to compute this value. It's 1 times 3 over 2 times 2, and then 2 times 4 over 3 times 3. Okay, so the main idea here Adam, I don't remember what I used. How do I change the thickness? All right. So the main idea here is canceling. Yeah. as Jennifer said. So the way we do this, let's look at how many times each one is in the numerator and the denominator. So in the numerator, there's 1, 1. Wait, I can't write. So okay, so there's 1, 1. How many 2s are there? There's 1, 2. And then there's 2 3s, 2 4s, all the way to 298. Yeah, there's 2 98s, 199, 1 100. And this is the numerator. So now let's look at the denominator. It might be easier just to cancel them, but it would be quite difficult to like keep track of it and see what's actually canceling. So let's look at the denominator. In the denominator, it's a lot easier. There's 2 2s, 2 3, 2 4, all the way to 2 99s. So now if we divide the two, numerator. Okay, somebody's crossing them out. I guess, sure, whatever. Numerator over denominator. Well, what's left over in the numerator? There's a 1 left over, and there's a 100 left over. So that's in the numerator. And the way we see this is because there's no 1s here, and there's 1 1 here. And there's also 1 100 here, and there's 0 denominator. And there's 0 denominator, or there's 0 100s in the denominator. All right, so in the denominator, what's left over? So there's 2 2s, while in the numerator, there's 1 2. So that means it's 2 times. And then also, you can notice there's 2 99s and 1 99. So that also creates 1 left over. So we just compute this, and this is 50 over 99. So the answer would be B. All right, let's do another question. Oh, okay, let's do number 1. Okay. Number 1. I'll let you guys do number 1. That's too much reading for me. Oh wait, I don't want to actually do this problem. So I'll let you guys do it, and I'll just give you guys a bit of time to solve this problem. Is it B or is it D? Let me think. So there's 6. Yeah, it should be D. All right, I guess I'll just write the answer real quick. So there's, in this problem, okay, so the answer is just 9, which is D. So the first part's just division to see how many sandwiches you buy. And then you divide again to see how many soft drinks you can buy. So that's it. All right, let's do another one. 11. Wait, after this problem, I might do a math. Should I do a math counts, or should I do AMC 8? So everyone type in the chat either Mathcounts or AMC 8. Mathcounts. No, let's not do IMO. You can check out Evan Chen's stream for that. Okay. Mathcounts is a different. Basically, there's two different contests. All right, let's do 11 first. So there are 93 students. Okay, and they're split either in math classes or foreign languages class. So let's draw a Venn diagram. Okay. Let's have this be math, foreign language. Okay, so there are 70 people taking math and 54 in foreign languages. So let's label these parts actually. This is A, B, C. So the 70 eighth graders take a math class. We have A plus B is 70. And then 54 eighth graders take a foreign languages class. So B plus C equals 54. How many eighth graders take only a math class and not a foreign languages class? Oh, also we know that the total is 93. Okay, so the only math class, not foreign language, is essentially this part. We want to find A. Okay, actually, now that I think about it, these letters in these equations are completely useless because you know the overall thing is 93. Wait, did I mess up? Wait, no, I didn't. Never mind. Okay, so there's 93 total, and then in B plus C, there's 54. So we have these two equations. And this first one's actually irrelevant, so I'm just gonna cross it out. So we have those two, and we want to find A. So what do? We subtract second and third equations. This gives us B is, or A is equal to 93 minus 54, which is 39. And 39 is just this answer. So the answer is D. Okay, I'm gonna do the math counts now. How do I find them? How do I find them? Tests. All right, do I do school, chapter, or target? Wait, no, school, chapter, or state? Go answer the chat. Oh, people are saying state. State or school? State's the hardest. Well, okay. Basically, every year, state is the hardest, but my score in state was 4 higher than my score in chapter, which means it was not the hardest. Oh, wait. This is this year's test. So I've actually never done this problem. Okay, let's see chapter. This is gonna be new for me too, because I've never done this test. All right. Which problem do we do? But random number between 1 and 30. Okay, let's see number 3. If x equals 1/2 and y equals 6, what is 12xy? Yes, the answer is 36. And the way you solve this problem is you multiply the numbers together. All right, let's do another question. Let's do number 8. Okay, so we have a geometric sequence. And I explained what this was 2 weeks ago. Okay, yes, it's 32. Basically, every time the number multiplies by 2. So the next one is 32. All right, let's have a question between 15 and 30. Okay, 16. Okay. Okay, so the way that I think you're supposed to solve this problem is you do like this square minus this square, but that's too hard. So I'm gonna just do something else.
I just wrote some lines and then counted them myself.
Yeah, let's just write. That's basically what I was gonna do. Okay, so you write some lines. Let's draw these lines. Okay, this is taking a while. Okay, basically we have a 5x5 grid. And now all that's left is just counting. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer is 10. Okay, that's it for this question. Next one. Wait, my computer. Okay. Let's do 25. Okay, maybe this one's harder. So we have 10,000 marbles. They split in these proportions. And you want to see how many enter through or exit through the bottom middle pipe. And it's just this bottom middle one. Okay. Because middle pipe does not necessarily indicate which one it is. All right, I'm probably gonna get this wrong, but whatever. I don't know the answer. I'm doing these questions for the first time too. All right, so okay, let's do like casework, okay? As I explained earlier. So the first case is that it takes this path. I don't know if it's 100, 200. I'll see. So the probability that it takes this path is 10 over 30 times 10 over 40. And this is true because the first one has 1/3 chance of going to the left because there's total 30 and it's like that proportion. And then the probability it goes to the right, the next one, is 10 over 40. This is 1/12. Okay, now let's look at the second case. The second case is if it goes here, like that. And in this case, the probability is 10 over 30 times 10 over 30. 20 over 30 times 10 over 30. This is 2/9. So we add these two together. And this is equal to 11 over 36. Wait, did I troll? I don't think this is right. Yeah, I think the majority of the people in this room have taken this test, but I haven't. Good idea. I'll check the answer. Oh shoot. Wait. Somebody sent me the wrong answer key. This is rigged. Okay. Wait, Charlie said to square it? 2/3. Oh wait, this is so bad. Wait, this question's very troll. All right, so if we read this again, it's split in proportional to the cross-section areas. And then these are the diameters. So we actually have to square all of these numbers. Let's just do this. 1/12 squared. All right, so now we have to add these up. 1/144 plus 4/9. This is equal to 37/144. I think. One sec, let me pull up these answers. Oh wait, how did someone get 4/? Oh wait, I'm so bad. This is 4/81. And now we have to compute this value. Okay, so this is equal to, does anyone want to do this adding for me? Okay, the reason why we're doing this, the reason why we're doing like a probability is because like just counting them, there isn't a very clear way to count this because like the proportions kind of get screwed up. Okay, I have the solutions up. Can you see the solutions? All right. Wait, I messed up this question again. Wait, this is actually so troll. Let me just restart this. So essentially, wait, Adam, I have the solutions in front of me. I just messed up. All right, so one sec. Okay, so let's look at this. The proportion of these areas is 1/4. So like, let's compute the probabilities again. The first one is 1/5 that it goes left at first. And then the probability that it turns right is 1/10 because it's 1 squared plus 3 squared. And this is 1/50th. So the probability for the first one, the first case, and we have the same cases as before, is 1/50th. And the probability that it's the second one is 4/5 times 1. Wait, did I mess up again? No, I did it. Never mind. Equals 4/25. So now we can add these more easily. And we get 9/50. And then 9/50 times 10,000. This gives the answer of 1800. And that's the answer. Wait, this was like a kind of confusing explanation. So does anybody have questions about this? Somebody might have gotten it before. I don't know. So this is the solution. And I would have missed this question for sure if it was on Mathcounts. It's 5:59. What do I do? Do I let you guys out? Do I let you go or do another question? All right. Thanks for coming. I'll send out some problems tomorrow, or probably tomorrow, because I don't want to do stuff today. And you should do them. Bye. Stop share.